Let us look at another such problem. So here a solid body is rotating with deceleration about a stationary axis, and the deceleration is given as beta is proportional to root of omega. Omega is the angular velocity instantaneous. Let us find the mean angular velocity of the body now averaged over the whole time duration of rotation. So again here we need to find out the total angle covered and the total time taken. So here beta, the angular deceleration beta, let us say beta is proportional to root of omega. So everybody should be familiar with the fact that acceleration can be written as v dv by dx. This is one very important thing to note. Similarly, angular acceleration can be written as omega d omega by d theta. This is important to note. Now since it is deceleration, there is going to be a minus sign involved. So this deceleration beta is going to be minus of omega d omega by d theta. So they are saying that this is proportional to root of omega. So I can write this equal to k root omega, where k is some constant. So this beta is equal to, let us say, k root omega. So based out of this equation, what do I get? I get minus root omega d omega is equal to k d theta. This is what I get. Let's get rid of this particular set of equations. Alright, so this is what we have. So continuing from here, we get omega raised to half d omega is equal to k d theta. Now initially it was rotating with let us say omega naught. Okay, initial is omega naught and final it's going to be 0, right? Final is 0. So omega raised to half, the integration of omega raised to half happens to be omega raised to 3 by 2 over 3 by 2. So this is going to be 2 by 3 omega raised to 3 by 2, and we have to substitute the definite integral limits omega naught to 0. The minus sign remains as it is. So it is 0 raised to 3 by 2 minus omega naught raised to 3 by 2. So the minus sign will now get cancelled and I'll get this to be 2 by 3 omega naught raised to 3 by 2. Now on integrating the right hand side, what do we get? Initially the angle covered was 0, then the angle covered becomes theta net. So the right hand side becomes integration of 0 to theta net k d theta. So that is simply equal to k theta net. Alright, so now we have found out theta net in terms of omega naught. Another important thing that has to be done is to find out the time. We do not know the time yet, so let us try to analyze and find out the time. So in order to find out the time, we deploy the regular equation beta is equal to minus d omega by dt, and this is given to be, because this is deceleration, and this is given to be again k root omega. So here we'll be able to write down omega raised to minus half d omega is equal to k dt. So this is obvious mathematical manipulation of the equation, and after we integrate this, we get omega raised to half over half. So the 2 from the denominator will come over here in the numerator, the 2 from the denominator of the denominator after integration. So this equation is after integration. Here we'll get kt. Now here the limits will be from initial value omega naught to 0. So this is omega naught to 0, and the limits will be 0 to time t. Alright, so we understand that if the integration is in dt, then the limit is not supposed to be like this. So let us say we put here as t naught. So let us say it takes a total time of t naught to stop. So here we'll get t naught. Now substituting, I am skipping a few mathematical details. I encourage the student to be complete in mathematical details in their mind or on paper. So here we'll get minus 2 into root of 0 is 0 minus root of omega naught. So it's omega naught raised to half with a negative sign. So the two negative signs will cancel out and we'll get 2 omega naught raised to half is equal to kt naught. So herein we have found out, the net angle covered in terms of omega naught, and herein we have found out the net time taken to cover that angle. So now what remains is essentially just to substitute and find out the answer. So omega average is going to be net angle covered upon net time taken. So net angle covered, as we can see, it is 2 by 3 into 1 upon k into omega naught raised to 3 by 2, and net time taken is nothing but 2 omega naught raised to half upon k. This is the net time taken. So we can see that the proportionality constant gets cancelled off. This is one important thing to realize. 2 is also getting cancelled, and we'll be left with omega naught divided by 3, because omega raised to 3 by 2 minus omega raised to half will give you just omega naught, and we are finding out the average angular velocity, so it has to be the dimensions of angular velocity omega naught only, and the 3 remains as it is in the denominator. So this is omega average. This is going to be our final answer. Alright.